Okay, now we'll start with the session. Hello everyone, greetings of the day. Dear authors and invited guests, welcome to the technical session 6C. Myself Prashi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology ICICT 2025 London, United Kingdom. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, United Kingdom, and the virtual event is being held through Zoom from 19th to 21st of February 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have six presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. On the 10th minute, I will be raising a gentle reminder. There is another request to all the participants that you all stay connected to us till the last closing remarks. If you have any queries or updates, then you can write it to me in the chat box given below. Before we start with our session, I would like to introduce you all to our session chair for this session, Professor Stephanus Rumkonkit. He is currently working as a lecturer at Bina Nusantara University, Indonesia. So welcome to the session, sir. Would you like to open with your remarks? Any suggestion to the presenters before we start with the session?
Okay, Miss Prasi. Okay, good evening all participant. Time in Indonesia. Introduce myself. My name is Stefanus Rumangkit. I am from Bina Nusantara University, Indonesia, and enjoy the moment and good luck. Thank you, Mr. Prasi.
Thank you so much, sir. Now I'll introduce you all to our next session chair, Doctor Meenakshi Memoria. She's an assistant professor in College of Computer Science, King Khalid University, Aba, Saudi Arabia, and her research and teaching interests include machine learning, grid computing, theory of computation, compliant design, operating system, intelligent system, data structure, etc. Ma'am, we welcome you to the session. Would you like to say a few words before we start with the session, ma'am?
Thank you, Anisha. Thank you for inviting me. Actually, I'm coming as a session chair in your conference since many years back. So this is good platform where students are coming and presenting their papers. So this is my suggestion for the students. Actually, I think so they should just discuss with the practical implementation of their paper. Like if they are just going to explain the theory, I think there is no need to explain that. So just go with the practical implementation, I think, and with the database also, they should mention. Then we can get the query from that. Thank you.
Thank you so much for your suggestion, ma'am. Now we'll start with our session. I would like to start with the papers. Our first presenter would be Given Shimalia, presenting on the paper titled "An Early Warning System Model for Chicken House Environment and Disease Detection Based on Machine Learning." If you are available with us, I request you to kindly take over the session with your presentation, please. So, are you available with us? Mr. Given, uh, sir, would you be able to present your presentation right now? You can write it to me in the chat as well if you have any technical difficulties. Okay, so maybe possible we have any technical issues on his side, so we'll just take on to the next. Okay, um, okay. So we'll take on the next presenter. Our next presenter is Ruqayya Majid Kareem, presenting on the paper titled Group Control Optimization Based on Gray Wolf optimizer from AC microgrid. If you are available with us, I request you to kindly take over with your presentation, please.
Hi.
Hello, ma'am.
Hi. Nice to meet you all.
Nice to meet you, ma'am. You can start your presentation. Ma'am, we can hear you right now. Is there any problem on your end?
1 minute, please. 1 minute, please.
Okay, okay. Have any problems? We can take the other participant right now. Is it okay for you?
أواجه مشكلة طلعت.
Ma'am Kareem, if it is not possible right now, we'll take any other person for the presentation. Okay. Your presentation is visible right now. And we can hear you as well. Would you like to start?
Presentation for me. Group control optimization based on Gray Wolf optimizer for AC microgrid. Outline. Introduction. What is microgrid? Concept of group control, power sharing, proposed methodology, simulation, result, conclusion. Dot emission. Emission the basal fall and security rising demand for electricity. Therefore, the world is training toward renewable energy resource. Like photovoltaic, solar energy, with when solar fuel cell. Consider the photovoltaic and wind energy are two most popular energy source. Integration distributed generator system that use the renewable energy resource to generate electric energy is necessary. This development concept a new concept of microgrid. And microgrid. What is the microgrid? Microgrid is a small scale. The small scale power system consists of various distribution generator, distribution unit, energy storage load, interconnected load. المicrogrid structure microgrid. This figure illustrates the structure microgrid from distribution generator. Like photovoltaic system or wind turbine and power electronic converter and energy storage system. Our load or utility grid. Type of microgrid. The microgrid various types, such as the AC microgrid. This figure illustrates the AC microgrid. Microgrid are source. Microgrid structure in AC bus is integrated and all microsource with variable frequency and variable AC output are connected to AC bus through AC to AC power electronic converter. Second type, DC microgrid. DC microgrid source with DC output are connected to DC bus directly, whereas source with AC output are interfaced to DC bus through AC to DC converter. The third type, the microgrid, hybrid microgrid. Hybrid microgrid structure, both the AC and DC buses are regulated. All source with AC output are connected to the AC bus. Source with DC output are connected to the DC bus through DC to DC converter. Both AC and DC buses are connected to each other through bidirectional converter. Microgrid operation in two modes can operation in grid connected mode and islanded mode or islanded mode. Concept of group control. Load control is a concept used in microgrid to control reactive and active power. As a result, it reduces the expense and the complexity of running the system. This concept is applied in inverter, basically reducing the reference of as load increases. This figure illustrates the relationship between active power and the frequency, and the relationship between reactive power and voltage. Power sharing. Power sharing meant to distribute the load between the available generating source according to their rated capacity in case in conventional source-based microgrid, and according to the available generated capacity according to renewable energy source-based microgrid, as whether dependent other term relating to power sharing include reactive power sharing, load sharing, current sharing, harmonic current sharing. Power sharing, accurate power sharing enhance the system voltage profile that lead to power equality enhancement. Inaccurate power sharing can overload small capacity distribution generator leading. Purpose control method in this paper, Gray Wolf optimizer. Gray Wolf optimizer Gray Wolf optimizer of swarm intelligent meta-heuristic algorithm is inspired by mimic social leadership hierarchy and hunting behavior of gray wolf in nature to hunt the prey while maintaining have discipline, have a very rigid social dominate that is divided into 4 categories: alpha, beta, and alpha, beta, delta, and omega, as illustrated in the figure below. Mathematical model of a gray wolf. The mathematical gray wolf consists various steps. Step 1, social hierarchy. Analysis social behavior involves backs and identify the fits candidate as alpha wolf. Our solution, however, with second and third best fitness are required beta wolf, delta, and omega. Step 2 encircling prey. The mathematical model for wolf is an encircling approach around the prey as follows in the equation. And step 3, hunting. Gray wolf recognize the position of prey and in trails. The mathematical regulate gray wolf hunt behavior. Consider the alpha, beta, and delta to better understand possible prey location. However, keep the first three best solution acquired. Thus far, those far and require remain search agent to update their position based on the position of this search agent by using the equation below. Step 4, exploitation. When prey stop moving, the gray wolf end their hunt by attacking them to represent approaching the prey. Step 5 and final. Gray wolf mostly based on the alpha, beta, and delta position. The split to mathematically describe in behavior. We use A with a random value higher than 1 or less than -1. Simulation result. This section analyzes performance. Gray wolf optimize the drop control and the BI controller and gray wolf Kepler optimizer algorithm for minimize frequency and voltage deviation microgrid. Using MATLAB scripts the connected gray wolf and gray wolf optimization and the Kepler optimization algorithm with simulating the microgrid output data were gated. Relevant data in 2 cases. Case 1, change in microgrid operation mode. The figure frequency analysis in gray wolf and gray wolf will Kepler optimizer algorithm and conventional. In the case when the microgrid change mode operator, the frequency in this case in BI controller show oscillation and unstable response, and the gray wolf provide smooth and fast response. The Kepler search algorithm, this is the oscillation and this is deviation. The voltage waveform similar to this of conventional gray wolf and Kepler search algorithm. The suggested system is stable and keep steady under under the same condition. In recorders with active and reactive power from significant overshoot before stabilization and concentrate, the gray wolf achieve big powers more quickly while reducing the oscillation. The Kepler method achieve balanced response. In case 2, when load change increase load, and in case 2 additional load are introduced steady microgrid to test performance of microgrid. Observe the BI controller show sharp frequency, and the gray wolf full Kepler search algorithm method provide good response with fewer oscillation. Regardless the voltage, the gray wolf is more consistent and stable than conventional BI, and Kepler. We observe that the two signals show slight difference in oscillation behavior. Regardless active power and reactive power, from significant shot before stabilization and concentrate, the gray wolf achieve big power more quickly while reducing oscillation. The gray wolf achieve balanced response. In conclusion, use two optimization algorithm, gray wolf and Kepler search algorithm optimization technique. Use the two to optimize our BI controller. Utilize often the optimal coefficient of the group control system and the gain of the BI controller. Thank you for attention.
Do our session chairs have any questions for ma'am?
I am one question, Miss Prasi,
Yes, sir.
and thank you, Miss Rukia. I'm very interested your research. But I have one question. Considering use of the GWO, Graph Wall Optimizer, and KOA, Kepler Automation Algorithm, to optimize drop control and PI control parameter in microgrid. And you can explain how is implementation GWO and KEO in real world industrial. Thank you, Miss Prasi.
Dr. Karim, would you like to answer that question?
Yeah, she has not given any answer.
Ms. Karim, ma'am, would you like to answer the question? If there is any technical glitch on your part, you can write the answer in the chat as well. I can read it out if it is possible for you. Okay, so looks like we have no response from ma'am's side right now. What we will do, we'll jump on to the next presenter with permission of Dr. Meenakshi and Professor
The
Stefanos?
research focuses on importance for energy sharing among distribution generation units in microgrid. While a real-world scenario, including load variation or simulation to demonstrate positive impact, the proposed method on grid stability and performance. The study show how to method constraints improve frequency and voltage. The difficult application real-world scenario.
Okay. Dr. Stefanos,
Okay.
did you get the answer?
Okay, thank you, Miss Karim.
Welcome.
Dr. Meenakshi, ma'am, do we have any questions from your end?
Yes, Rukaya, actually, I just want to ask from where you have collected the data set for this optimizer.
This result show the robust method from simulink in MATLAB.
Okay, MATLAB. Okay, it's okay, thank you. Now we can move to the next presentation.
For sure, ma'am. Now I'd like to call upon the next presenter. Uh, just a second. I have Mr. Given. He was asking us if he could present now. Sir, if you are available with your presentation and you have no issues with the PC, you can start out with your presentation, sir.
Can you hear me?
Yes, sir, we can hear you.
Okay, thank you very much. Just a minute. Okay, are you able to see my screen?
Yes, Mr. Given.
Yes, sir.
I
Now we
see
are
your
able to.
presentation.
Okay, okay. So just a minute. Okay, so thank you very much. I'm Given Chilima, and I'm glad to present at this conference today on the paper titled An Early Warning System Model for Chicken House Environment and Disease Detection based on Machine Learning. Okay, so just to give a brief, maybe let me say a summary of this research, the way it was done. So in this research, we developed a model for detecting poultry diseases using machine learning, specifically CNN, convolutional neural network. So CNN are widely used in image analysis because it can automatically extract important features from images, making them ideal for our task. So our model was designed to classify into two categories, which is unhealthy images, which is fecal images, and healthy images. So unhealthy, to be specific, we're looking at the two categories. So the unhealthy one is coccidiosis disease. So just to move forward, this is just the outline. So going to the introduction. So in the recent years, poultry diseases have caused a big problem for chicken farmers. These diseases do not only make farmers lose their money, but also pose a risk to human health as well. So despite efforts that have been put in for disease prevention and control, such as breeding disease-resistant chickens and using immune-related products, diseases still occur. So just a bit background about the research itself. So poultry farming is important for producing meat and eggs, but diseases can harm chickens and cause financial losses as well. Currently, methods used to detect these diseases, like looking at chicken behavior, are not very, very accurate, or they are not always accurate, and sometimes they can be slow. Okay. So modern technologies such as machine learning, deep learning can help improve disease detection. machine learning can analyze chicken images to find the diseases. So for this purpose of this study, the CNN model was designed specifically for early disease detection in Zambia. The purpose for providing early detection in poultry farms, enabling a proactive disease management strategies for farm owners. Okay, so the problem statement, of course, I mentioned in the previous slide, such as visual observations. So farmers often rely on their observations for chicken behavior. They may also observe physical signs like changes in feather condition, eye or nose discharge, okay? Hence, the implementation of the early warning system for the detection of chicken disease by analyzing fecal images using AI technologies like machine learning could potentially overcome these challenges by providing immediate and reliable disease detection, empowering farmers to make proactive decisions for enhancing chicken management. Okay, so the aim of the study, of course, the aim of this research was to develop a model that can detect, diagnose, and classify chicken diseases by analyzing fecal images like coccidiosis disease and health images in the poultry houses. Okay, so these were the two main research objectives, which is to build a model that could actually automatically detect and classify the diseases with a primary focus on coccidiosis disease and the health fecal images. Also to develop a web-based prototype for detecting and classification of the diseases. Then the research question, how can we develop an effective model for automated chicken disease detection and classification with a focus on coccidiosis by analyzing fecal images? The second one, to what extent can a web-based prototype be developed that can employ machine learning techniques to utilize chicken fecal images for the detection and classification of chicken diseases? So the significance of this study was the early detection of the early warning system using artificial intelligence like machine learning and deep learning offers a significant benefit in terms of disease management, thereby positively impacting the chicken farmers. So because of time, let me just go straight to, so this is the literature review. As we can see in the literature review here, you see that most of the research that were done, they were actually focusing on CNN, which is very good when it comes to analyzing images and doing the classifications and all that, okay? Okay, so the methodology of how this was done. So the data set, we used the data set of labeled chicken fecal images containing disease and unhealthy images such as coccidiosis and healthy ones. So we used the programming languages and libraries. Python, of course, was used along with machine learning, deep learning libraries like TensorFlow, and other supporting libraries like NumPy, Matplotlib, and Pandas. Okay, then on the hardware side, use the computational resources, including power, CPU, and GPU, and also Google Colab was used, of course. So this is just a sample of the images that were collected from the local farms just around an area where we're collecting data from. Though 2 experiments were conducted, I'm going to mention about this. So the image, this shows the healthy data set, okay, that was captured from the chicken run. And then the second one shows the coccidiosis data set, which was also collected from the chicken run. So this is simply the configuration on the fully connected proposed model, okay? This is the CNN. As you can see here, we have an image, okay? On the input layer, of course, we have an image of, it could be any image during the training phase or the designing of the architecture itself. So we have the input layer, then we have the hidden layers where we used certain activation functions like ReLU, and on the output layer, since we're focusing on the 2 categories, we use sigmoid function, which works very well when you're looking at the binary classification. Okay, so of course I've mentioned we used in the hidden layers, we use ReLU activation function. Okay, so ReLU activation function is used in the hidden layer to just introduce the non-linearity and improve the learning efficiency. Then in the output layer, of course, we have sigmoid function, which gives the probability score. Okay, so the findings, so after multiple epochs or iterations in the training process, the model was successfully trained. The training and the validation loss was monitored to evaluate the model's performance and determine if it was learning effectively. The loss, which is a measure of how well the model is able to make predictions compared to the ground truth labels, whereby the training loss represents how well the model is fitting the training data. Okay, so let's see the figures below. So on the first one, this side, we can see that both training and validation accuracy increased rapidly, indicating that the model is learning from the data itself. The training accuracy increases more steadily than the validation, okay, which is the unseen data. So meaning after from the seen data, the model began increasing, it started learning, in short. Then on the training versus the validation loss decreases, but not as sharply as the training loss, and begins to flatten out, indicating that the model is improving less on the unseen data. So now, two experiments were conducted here on the findings. Two experiments were conducted. Okay, so the first experiment, so about 60% of the data was collected on cargo. Okay, and which was the training. 60% of the data was used on the training side from cargo, and then the local data set, which was about 40%, was the data that was collected locally and to just train the model. And we can see that the accuracy was about 84.99%. And then in the second experiment, this is where now we used both local data set on the 80% training and on the 20% testing. And we can see that the model was improving in terms of the accuracy itself. Okay, so conclusion and recommendation. A machine learning model for detection of chicken diseases was built and successfully trained. At the end of the training, the accuracy of the model achieved about 84% and 90% respectively. So for recommendations for future research, we could focus more on expanding the dataset so that it can just balance up to avoid maybe overfitting and underfitting of the model. To introduce more diverse disease types, of course, not just limiting on coccidiosis, maybe we could focus more on other diseases as well, okay, to optimize the model to improve the robustness and real-world applicability. Okay, so thank you very much. This is the end of the presentation.
Thank you, sir. I'd like to ask our session chairs if they do have any questions for you. Professor Stephanus and Dr. Meenakshi, do we have any questions for him?
Okay, Miss Prasi, I have one question.
Yes, sir.
Is Mr. Given. My question is, considering the potential for disease detection in poultry farming, how do you envision the adoption of technology in this research in resource-limited environment, especially in developing countries, and it is easy to implement? How you can explain? Thank you, Miss Given.
Sorry, can you just repeat the question again, please?
Oh, okay, Miss Given. My question is, considering the potential for disease detection in poultry farming, how do you envision the adoption of technology in this research in resource-limited environments, especially in developing countries, and it is easy to implement? How can you explain, Mr. Given? Thank you.
I don't know, but I still don't get the question. Maybe if you can simplify it.
Okay, my question is uh, result your research easy to implement in developing countries or not?
Yes,
You,
it's just for the developing countries, yes.
okay, why, Mr. Given?
Because when you look at developing countries, you find that, well, a lot of people don't waste a lot of time, by the way, when it comes to disease detection in these poultry farms. Whereby they rely so much on the traditional way of managing these diseases, whereby they'll just look at it and sometimes they make wrong predictions by face. And then so looking at how AI has come in, machine learning, deep learning, to just help um, uh, in this disease detection at a faster rate so that they can now apply proactive disease management could actually really help these developing countries. Yes,
Okay, thank you, Mr. Given.
thank you.
Thank you so much, sir. Ma'am, do we have any questions from your end?
Yes, I just want to ask, if you are collecting the data set, like you are working on the live data also. So one more thing I want to ask: are you working on only the images or the current videos also?
No, our focus was only on the images for this particular research.
So are you capturing the live image, or you are having the existing data set on which you are working?
No, we had, when you look at the two experiments that were conducted, first we were just capturing images using phones from the chicken run. That's for our local dataset. Using phones, and then we performed what we called data augmentation techniques, like resizing the image and just putting them in a proper shape, the lighting and all those data augmentation techniques.
Okay, how many existing existing images you are having in your data set? What is the size of your data set?
On the one we collected from cargo or the one that we collected locally?
So what is the size? What is the size of your data set you are using?
Okay, so
And
on
how
the
much
two X,
optimization you are getting?
okay, so the data that we collected locally was about 500, which wasn't really a lot, of course, but then the cargo data set was about 1,500 images.
Okay, and what is the accuracy you are getting by that?
So the accuracy after training the model from the cargo dataset and then testing it on the local dataset, the accuracy was 84%. But again, after performing another experiments where the local dataset was used both for training and testing, the accuracy improved to 90%, which means the model kept on learning from the
Okay, okay,
data.
then it is good. Good. Thank you.
Thank you.
Thank you so much. Now we will go for the next presenter for the session. I would like to invite our next presenter, Ahmed Abu Khadr, presenting a paper on the title Enhancing IoT Security and Malware Detection Based on Machine Learning. Sir, if you're available with us, I request you to
Yes,
kindly take over the presentation.
yes. Good afternoon. I am available, but let me share the screen.
Sure, sir.
Do you see my screen now? It is visible?
Yes, sir, now it is visible.
The presentation, yes?
Yes, sir.
Okay. Okay, let me start at the first. Good afternoon for everyone here in this session. Today, inshallah, I will present or my research work. The title for my work is Enhancing IoT Security and Malware Detection Based on Machine Learning. The outline for my presentation is started with the introduction. After that, we're talking about problem statement and objective, lecture review, research gap, methodology implementation, at the end research result and discussion, and research conclusion and the future work. At the beginning, in my introduction, in today's rapidly evolving technology and space, the Internet of Things has emerged transformative force, connecting billions of the devices and generating vast amount of data. However, this connectedness also presents the significant security challenge, particularly in ensuring the authenticity of devices within the IoT network. Malicious actors can exploit vulnerabilities in these devices to gain unauthorized access, disrupt the data, and also may compromise sensitive information. Now, IoT devices are used in different areas such as smart homes, healthcare, transportation, smart manufacturing, cars, and many others areas. The main challenges of this IoT devices now is security. Okay, to achieve the security, our high level of security for the IoT devices. A problem statements. Traditionally, we're using in the normal network firewalls and intrusion detection system may not sufficient for the IoT. Aims in this project is to develop a model to enhance the security by combining three machine learning. That's mean we want in this research we combine three machine learning together using voting between them to decide if this software is malware or benign. Okay. Objectives for my projects: to use comprehensive data set to perform malware detections for IoT devices, to develop new models to enhance malware detection by using super vector machine bagging and KNN algorithms. Okay. And also at the end, we want to evaluate the effectiveness of the proposed model by measuring accuracy, precision, recall, and F1 score. The lecture review for this research here we can find like the most important lecture review that I use it in this paper. Okay, the first one talking about comprehensive review of the machine learning. The second one evaluate the current machine learning tendencies in the IoT security. The third one explores IoT security challenges and improvement using machine learning. The fourth one discuss the physical security IoT machine learnings, and the last one emphasizes machine learning security threats. All or most of the lecture review that I put it inside the paper using one machine learning to detect the malware. The gap that we want to solve it need to enhance this accuracy. Okay, to get more accuracy, to be more accuracy when you catch malware software. Okay, based on the related work, it has been revealed that majority of the utilize one single machine learning algorithm. So they have reached the acceptable accuracy, but we want to reach more. It does not consider the best, especially for the something really critical, such as IoT devices. In order to improve the accuracy prediction, a new model that combines between more than one machine learning is proposed in this paper or in this presentation. The methodology that we use it at the first, we select comprehensive data set. Okay, it includes about 11,000 the samples. Okay, after that we're going doing smooth for the data set. That's mean to make it is balanced. After that, feature selection. Then we divide the data for 80% for training and 20% for testing. After that, here our work is to our proposed algorithm. That's mean we want to combine bagging, KNN, and super vector machine, and using voting to decide if it is benign or malware. If it is deny or here our proposed algorithm that combine between three machine learnings and using voting to select if it is benign or malware. After that, we want to evaluate our results as we normal step in the AI. We want to calculate accuracy, recall, precision, okay, and F1 score, and want to see if our model enhance the accuracy or not, that we want to show you in these next slides. When we were doing implementation, at the first we importing Python libraries, and after that loading dataset, feature extraction using the smooth for balancing the data. After that, split the data for training and testing. Model building by using combine between KNN, bagging, and super vector machine. Model evaluation and using the votings for the model buildings. After that, final evaluation by calculating the or measures the accuracy, precision, recall, and F1 score. To assess the model performance, we use some evaluations for our classification task. We use most common evaluation metrics such as accuracy, precision, recall, and F1 score. To address imbalance nature of the data, we using the smooth, okay, smooth to making the data balance. The data set we using the Kaggle website to get it. It is labeled data set. It contains 11,500 data sets out of 7,776 malware and 3,723 benign. Choosing the suitable features that will be used in the training of our model will strongly affect the performance of our result. Here in this slide, I will show you the result that we get it. Okay, the accuracy is 95.76%, precision 97.01%, recall 94.55%, and F1 score 95.77%. Okay. This study demonstrates that the effective of a simple machine learning approach for the IoT malware detection, combining K and N bagging and super vector machine, okay, which achieve overall 95.76%. The proposed algorithm shows superior performance with accuracy 95.76, okay, surpassing the when we use CNN just only alone machine learning, it was 93.17. If we use GPost 90.83, and if we use random forest only 91, just only 91. That's mean when combining or using our proposed algorithm with combining these three super vector machine bagging KNN, we'll see that we got high accuracy and also high value in the AI metrics that we want to measure it, such as accuracy, precision, recall, F1, and phone score. Here in this table, we compare our result with the other researcher. Okay, you will see here accuracy, we achieved 95.76, as we said before, precision 97, recall, and also F1 score, it is the best from another, and we here and we calculate the average. That's been our algorithm or our proposed algorithm enhance the accuracy of detection the malware in the IoT devices. Research conclusion and the future work. This research shows that the efficiency of the innovation is simple machine learning methods for detecting IoT malware by integrating or combining KNN bagging and super vector machine, achieving accuracy was or is 95.76. While the researchers are promising, the study highlight the need for further investigation in the model's generability across the diverse of IoT malware threats and varying device configuration, as performance may vary with the different data set. This is my presentation for my research. If you have any question.
Thank you so much, sir. I would like to ask our session chairs, do we have any questions for sir?
I have question, Miss
Yes.
Prasi. Hello, Dr.
Yes.
Ahmad.
Yes, I hear you, but if you can speak more higher, I cannot hear you well.
Okay. This now you can hear me?
Yes, it is okay.
Okay. Mr. Ahmad, I have two questions. The first question, what is the novelty this research compared to previous study? And the second question, can you give me example of implementing IoT in healthcare based on the result of your research. Thank you, Mr. Ahmed.
Okay. At the first, my novelty for this research is to combine more than one machine learning. It is usual for the other researchers, most of them using two machine learning, or one machine learning, single machine learning, and some of them using two machine learning. In this research, we combine between 2 or 3 machine learning to enhance the accuracy. This is the novelty, and why we select the 3, like to have to get the more accuracy result when we're doing the voting inside the AI, or inside the AI step to evaluate our results. This is our novelty in this research. For the second question, where we can apply this algorithm, we can apply it in any IoT devices, but need more RAM, or space inside the IoT, and we can apply it. It is and give us good result, inshallah. I hope that.
Okay, thank you, Mr. Ahmed.
Okay, thank you.
Thank you, sir. Dr. Meenakshi, ma'am, do we have any questions for the presenter? Okay, looks like we don't have any further questions. Thank you so much for your presentation, sir. Now we would like to jump on to the next presenter for the presentation.
Thank you.
Thank you so much, sir. Our next presenter is Hong Miu Tion, presenting a paper on the title Fake Beef Detection Using Lightweight Convolutional Neural Networks. If you are available with us, I request you to kindly take over with your presentation, please.
Yes, I am.
You're available. Thank you so much, sir. I'll just stop sharing and you can go ahead with your presentation.
Okay. Can you see?
Yes, sir. We can see the screen right now.
Hello, everyone. Today I will talk about fake beef detection using lightweight convolutional neural networks. My name is Hoàng Minh Tuấn. First, we are going to introduction. The problem. A fake beef is a growing issue, accounting for 20% of the market and posing serious health risks to consumers. Fake beef is much cheaper, only 1/3 the price of real beef, yet looks nearly identical in color and texture. This chart illustrates the market percentage of fake beef, showing the scale of the problem. There are several detection methods exist, but have limitation. About DNA barcoding is highly accurate but expensive and requires specialized equipment. The spectroscopy like NIR, FTIR, Raman is not destructive but sensitive to environmental factors, and AI methods have the potential but often require large datasets and struggle with chemically modified mist. About our hypothesis, we propose that a convolutional neural network CNN can distinguish real and fake beef through image analysis, making detection faster, cost-effective, and more compatible. To give a clear picture, here is comparison of the existing detection methods. While some are accurate, they are often costly, slow, or require expert knowledge, making them impractical for widespread use. Our CNN model aims to be accurate, fast, and affordable, addressing these limitations. Our objective focus on three keys. First, develop a CNN model to accurately classify real and fake beef. Second, evaluate its performance on real-world datasets. And finally, assess its feasibility for mobile deployment. The significance of the study. So why is it research important? First, it enhances food and safety and protects consumers from low quality products. Second, it supports businesses and regulatory agencies in monitoring the supply chain. Finally, it demonstrates how AI can improve food quality control, making detection more reliable and accessible. With mobile-based detection, this technology can be used in the supermarkets, restaurants, and even by everyday consumers. We are going to introduce our methodology, the CNN detection process, and we collected the image from multiple sources and categorize them into two classes. The rebip, we collect source from ICICT and the logbip dataset, high quality created from for retelling. The fake bip are collected from ICICT, Soha, and other sources in the internet. To improve robustness, we also include pork and buffalo meat since they are common substitutes. Additionally, we incorporate samples from the meat freshness image dataset, while primarily contains pork image to further diversify the dataset. The dataset split into 70% for training and 30% for testing to ensure balance and learning evolution. The pre-processing, we apply segmentation and augmentation techniques to improve model performance. The segmentation is extracted the mid regions using HSV-based color resolving, remove background noise. The augmentation apply transformations such as rotation, flipping, brightness, adjustment, and Gaussian blurring to increase dataset diversity. These pre-processing steps help the model generate better and recognize key patterns for more effectively. The feature extraction and classification. Our CNN model follows a structured deep learning pipeline. The convolutional layers extract the detail, texture, and pattern information. The pooling layer reduce dimensionality while reversing key features. The fully connected layers align the extract the feature and classify image as real or fake bip. By leveraging CNN's ability to recognize fine grain differences, we ensure high accuracy and reliability. The output and prediction. The final output is a classification label real or fake bip along with a confidence score. This allows for automated scalable mid verification, possibly deployable on mobile cameras or quality control systems. Now let's analyze the result of our study. The CNN performance. We evaluated the CNN model's performance based on accuracy and loss metric. We can see the training accuracy is 91.94 and validation accuracy is 91.09. This indicates that the model not only learn well from the training data but also generalize effectively to unseen data. Now we can see the conversion matrix. The conversion matrix shows minimal misclassification, demonstrating that our CNN effectively differentiates real and fake bip. It is very low conversion between real and fake bip, and model effectively distinguish categories and minimal errors. about optimization with MobiNet V2 to further optimize our approach. We apply transfer learning using MobiNet V2, a lightweight and efficient and CNN architecture. The key of the improvements, the accuracy increased from 91.09 to 95.13, and the model size reduced from um, 294 to over 10 MB, and inference time increased slightly from 0.5 0.55 and to nearly 2 seconds. These improvements make our model more practical for real-time application input authentication. Finally, we are concluding our project. To conclude, summary of key findings. Our AI-based approach successfully distinguishes real and fake beep with high accuracy. The CNN provides high accuracy, but the MobiNet feature is more practical for mobile application. The challenge remains such as lighting condition and dataset diversity requiring further improvements. The practical implication, the AI power mid detection can enhance food safety and transparency. The potential application include mobile apps for customers and automated quality control in food supply chain. The future work and next steps, we are going to expand the dataset with more real-world fake beep samples and enhance model robustness against lighting and stricter variation, and optimize lightweight AI models for real-time mobile deployment. This improvement will make our model viable for real-time food authentication application. And that concludes our presentation. Thank you for your attention. I'm happy to take any questions.
Thank you so much, sir. I'll just ask our session chairs if we have any questions for sir.
Okay, Ms. Prasi, I have one question
Yes, sir.
to Mr. Hoang. Mr. Hoang, I appreciate your research is very good, and I have one question. You can explain, Mr. Hoang, advantage your method in your research of detecting fake beef comparing other method. Thank you, Mr. Hoang.
Can you repeat your question? This
Okay.
detection, how to detection thing fake beep and real beep?
Yes, yes. You can explain the advantage your method in the research of detecting fake beef, Mr. Hoang.
We use the available available model like the ReNet and CNN to detect the first we use the retraining with the real beep of and fake beep to distinguish the texture and the color. The my model auto chain this the texture and color of beef, and they can detect the difference of real beef and fake beef.
Okay, Mr. Hoang. Thank you for your answer.
Thank you, sir. Dr. Meenakshi ma'am, do we have any questions for sir from your end?
Yes. Can you just tell me what is except your future scope? Can you just tell me any deficiency of your project? Hello.
I think this model can develop in the future. If it can accept in my school, I will improve this model to an app in app of mobile phone. For everyone can use this app to distinguish real and fake beep. I think the efficiency of this project is this can detect any picture that not enough brightness or this my model not enough data of fake beep because fake beep the picture of fake beep is very hard to collect, and I think this is our deficiency of my project.
Okay, Anisha, we can move to the next presentation.
Okay, ma'am. We'll take on the next presenter. Thank you so much for sharing, sir.
Thank you.
Thank you. Our next presenter is George Komani Agare, presenting the paper on the title System Integrity Framework for Evaluating the Effectiveness of KNUST Enterprise System, a case study of a Ghanaian university. If you are available with us, I request you to kindly take over with your presentation, please. So, George, if you are available with us, I request you to kindly take over with your presentation,
Hello.
please.
Hello.
Yes, sir.
Yes, this is Emmanuel. I think the presenter is not is having a problem with the network at the moment. Network connection.
So could you write this
So
to?
I think if I can stand in for him to the presentation. Hello.
Hello? Yes, sir.
Hello.
Okay, looks like some technical. Okay, you have text. Okay.
Hello.
Yes, sir.
Please, can you hear me?
Yes, sir, we can hear you, but there is some glitch because it is not audible completely when you speak.
Yes. What I'm saying is the presenter is not currently having a challenge with the network.
Okay.
So if I could stand in for him to do the presentation.
Yes, you
for
can
him.
do the presentation for him, sir. Yes, please take over because you're a co-author, I can see from here.
Exactly. Okay.
Okay, if it is possible for you, I request you to kindly take over with your presentation.
Okay.
Yes.
Okay, please, I hope you can see my screen.
Yes, sir, your screen is visible to us.
Okay, so our research title is System Integrity Framework for Evaluating the Effectiveness of KNUST System, case study of Ghanaian University. So the main author is the George Kwame Gray, and maybe a couple of and then Manuel Peters. Now, introduction. ERP systems are integrated information systems popularly used among tertiary institutions in the world. ERPs has attained familiarity or familiarization across the globe due to its huge acquisition in tertiary institutions. It unifies all departments, sections, such units, and within the university, ensuring seamless flow of information and preventing data duplication. Across the globe, numerous higher education institutions have acquired integrated ERP systems to enhance students' lifestyle and support faculty in managing their teaching and administrative responsibilities. Notwithstanding the rising acquisition, choice and execution of ERPs in higher education, there remains a scarcity in literature about their performance, especially in the developing world. It is therefore important to further examine whether these ERPs fulfill their anticipated benefits. This paper aims to use the KNUST enterprise system, that's comprising EMIS, Panacea, and Synergy systems, as a case study to evaluate the effectiveness of ERPs in case through a system integrative framework. Now, our problem statement is, in the developed countries, studies such as Malik and Gar and Khan, 2021 and others, have shown that ERPs in the higher education sectors are effective and that they are helping to achieve their set objectives or expectations. Studies about ERPs in the developing countries such as discussed by Fisher 2024 and others show little or scarcity of literature on the performance or the effectiveness of ERPs in the case. Again, there's also no proper safe integrating framework for evaluating the performance of ERPs in place, according to Shem and Mayu 2024. Now, prior research efforts that people have done about this study is that a lot of studies have gone on with the ERP system, but there's still a challenge. None has focused on using system integrated framework, which combines the BS framework, the ISO model, safety cube theory, to evaluate the performance of ERPs in the case. Our research gathers that there's no system integrated framework which combines the BS framework, the ISO model, safety cube theory found in the literature that assess thoroughly the performance of ERPs in case. Now, why address such a gap? The gap is addressed to help increase the knowledge base of ERP systems and to thoroughly evaluate the performance of ERPs in the performance of KNUST system. The rationale of the study: ERPs are strategic information systems that affect every aspect of an organization. Many organizations and institutions in Ghana are increasingly adopting and implementing ERP systems. However, ERP's evaluation researchers have been forgotten by many researchers. There's a surprising lack of research on ERP systems evaluation in developing countries, especially in Ghana, given the importance of these systems to the economy. Now, our study objective over here is to evaluate the effectiveness of ERPs, the effectiveness of KNUST enterprise system, which is composed of the EMIS, the Panacea, and the Synergy systems in tertiary education via our system integrated framework. Now, the literature review, we reviewed theoretical literature about safety cube theory, about balance scorecard framework, and about the ISO 25010 model, and the proposed system integrated framework, which combines these theories above. Now, the empirical research theories, other empirical studies such as this, Gar and others 2022, Nabati and others 2023, Sulemana and Nausea 2022 and others have documented works on ERP's evaluations, implementations, critical success factors, and challenges, but none has focused on using system integrated framework, which combines the BS framework, the ISO model, and the safety cube theory to evaluate the performance of ERPs in the case. So this is our research framework going into the study. So we combine the BS framework, which comprises of 5 perspectives. Then we use the ISO 5010 model. Also, which also has these features. Then all these with the safety cube theory as a center of combination form our system integrated framework as you've seen on the diagram. So we have 5 perspectives of our system integrated framework, which go into the framework. Hello? So this is our system integrated framework. Then our research methodology. So we use research, our research paradigm is positive-based framework. Our research method is quantitative research. Research format is causal explanatory research. Data collection method use is primary collection and interview, but we use both questionnaire and then interview to perform this research. Then our questionnaires are semi-structured questionnaires. Then data analysis uses PSM analysis. Research strategy is case study. Our research population is all HAs in Ghana who have implemented ERP systems. Then our unit analysis is the university administrators and managers. Then a sample technique used is probability and purposive sampling technique is used to collect the data. Then a sample size is 60. That's the case study done at the KNUST is 60. So the breakdown is what you see. So at the finals, we interviewed 20, or we did questionnaires of 20 finance officers. Then the human resource 15, academic affairs 15, then the payroll section we did 10. So in all, summing up to 60 sample size that was used for this analysis. Now, our analysis of results, we use the PSM to analyze the quantitative study. So in the PSM, we use the measurement model assessments, which we test the reliability of the constructs, which give us which is acceptable level of 0.7. Then reliability indicators also test, giving us 0.4. Then convergent validity, AB test, which is 0.5. Then the discriminant validity test was also performed. So this formed the measurement model assessment of our analysis. Then for the structural model assessment, we investigate the coefficient of determination, which is R squared, that we use the PSM algorithm test. Then the Songazer Q squared, that using the blindfolding test. Then the standard path coefficient theta and their significance, we also investigate with the bootstrapping test. So this is the PSM structural model assessment for the K University enterprise system. So the blue indicators are the constructs which we investigate, while the yellow are the indicators. So the construct and their indicators with their individual values showing there. So testing the effectiveness of that. So our major outcome of the study, the findings of our study show that customer stakeholder perspective has a significant impact and positive relation with the K University enterprise system. Financial perspective has a significant impact and positive relation with the K University enterprise system. Internal business perspective also had an impact, had no impact on the effectiveness of the K University system. Learning and growth perspective has a significant impact and positive relation with the K University enterprise system. Then system quality perspective significantly impacts the effectiveness of the K University enterprise system. Then our qualitative analysis of the study by the using the inductive thematic analysis also showed support for the quantitative analysis done by the PSM analysis. So in conclusion and the finding implications, the findings of this research together make our study very unique and comparatively fulsome as it addresses the problem statements and the research objective. One practical implication of this research findings is a suggestion that case management and other stakeholders should consider critically the financial, customer stakeholder, learning and growth, and system quality perspective. These four perspectives when evaluating their ERPs. Since effectiveness of ERPs depends on them. And one policy implication of this is the recommendation that frameworks that will guide and our system effectiveness. These policies and frameworks will help PACE to come up with effective ERP systems that influence management decision making. So that is the end of the presentation. Thank you.
Thank you so much for your presentation, sir. Now I would like to ask our session chairs if they have any questions for you.
I have question, Miss Prasi. Hello,
Yes.
Mr. Emmanuel. I have
Hello.
two questions, Mr. Emmanuel.
Okay.
The first question is, you can explain how you build a questionnaire and how you distribute questionnaire. In the first question and this question, and the second question is, why you use Smart Palace to data analysis? Thank you, Mr. Emmanuel.
Yes, please, your second question again. I didn't get it clear. If you can repeat it.
Okay, I repeat again, Mr. Emmanuel. The first question is how you explain about you build to questionnaire and how you distribute questionnaire. And the second question, why you use Smart PLS to data analysis? Understand my question, Mr. Emmanuel?
Yes, the second is the smart analysis. Why are we using smart analysis? That's the second question.
Yes, Mr.
Yes,
Emmanuel.
okay. Good. So the first question, the questions, because we are doing a case study research. So the method that we are using both qualitative and quantitative analysis, the two combined. So we use questionnaires to analyze the quantitative analysis, and we use the qualitative, that's the interview. So we only interview some few, I think either 5 of our unit analysis. That's the administrators and then the users of the system. We interview 3 of them, only 3 questionnaires to 60 of the administrators and then the users, those who are using the breakdown. I think I give the breakdown in the analysis part. We have I think the finance, we distribute 20 questionnaires to them. Then at the human academic section we distribute 15 questions. Then at the stores, we also distribute 15 questions. And then at the human resource, 10 questions. So making 60. So this is how we distribute our questionnaires to the people, the administrators and the users of the K University system at the K University and University. So that's what we did. And the PSM analysis, which is the second question, because we are doing case study, we are using a smaller sample size of 60. The analysis that can to perform such, we use that just to help That's why we don't end up research and cause-effect research. Mostly, if you apply the PLSM analysis, it helps to bring out the solutions or the findings that you are looking for. So that's what we adopted. We adopt the PLSM analysis for this case study.
Okay, thank you, Mr. Emmanuel, for your answer.
Thank you very much.
Thank you so much, sir. Now we'll call up the next presenter for the session. Okay, sorry. Ma'am, do we have any questions from your end?
Actually, I wanted to ask the question, but sir has already asked so many questions, so I am satisfied now. So you can just move with the next presenter.
Okay, ma'am. Thank you so much. So we'll go over the next presenter and the last presentation of this session.
Hello, good afternoon.
Yes, sir.
Hello.
Mr. Jimmy Katabo, presenting a paper on the title Understanding ENSO Teleconnections Influence on Drought in Southern Africa, a Machine Learning Approach. Thank you so much, sir. You can start on with your presentation.
Yes, good afternoon. Are you able to get me clearly?
Yes, sir. We
Are
are
you
able
able
to hear you clearly.
Okay, okay. Let me share my screen then.
Yes, sir.
Are you able to see the PowerPoint
Yes,
presentation?
sir. It is visible to us.
Okay. Yeah, so my name is Jimmy Katambo. I am from Namibia University of Science and Technology, NAST, and then the co-authors are Gloria Iyawa, Las Rib, and Victor Congo. The title of my paper is Understanding Enzo Teleconnections Influence on Drought in Southern Africa, a machine learning algorithm, a machine learning approach. The outline is as shown here. Enzo-driven sea surface temperature variations influence drought conditions across Southern Africa. How does a phenomenon in the Pacific Ocean control droughts thousands of kilometers away? By altering atmospheric circulation, which may lead to rainfall and temperature changes, which results in drought or flooding. What was the focus of the study? The problem being examined has to do with the improvement of prediction accuracy or forecasting. Yeah, so this is still an area in research where we have current systems that may not be accurate enough. Literature from some papers such as 1, 2, 3, 4, and 5 show us that SST plays a critical role in climate modeling variability. There is need to refine our understanding of how SST variations interact with local climatic processes to influence droughts at a more detailed level. Studies specifically using machine learning approaches to assess the role of SST in regional drought dynamics remain limited, particularly in Southern Africa. Therefore, the objective was to investigate the teleconnection relationships between El Nino Southern Oscillation and standardized precipitation evapotranspiration index drought across the different regions of Southern Africa. Under the methodology, the approach that was used can be summarized by this conceptual framework for the algorithms based on tasks and objectives. Under the methodology part 2, first of all, the station identification was done, and the stations were then grouped according to climatic zones. Yeah, and then the data was extracted. There are two types of data, the one from the stations and then the satellite one. So the satellite one was downloaded using Python codes. And then apart from the data set, which is shown under climate data, which has variables precipitation, minimum temperature, maximum temperature, average temperature, wind speed, relative humidity, solar radiation, sunshine hours, soil moisture, and runoff. There was also another data set which was used, which is sea surface temperature. So in the same way, we had to identify stations which had sea surface temperature and then the data extracted. Under the machine learning modeling, there are three algorithms that were selected initially: random forest, feed-forward neural network, and transformers. And then when an initial experiment was done on these, then the one that merged to give, or maybe the one that gave better metrics in terms of performance was the transformer, based on the data which was used. So it was then the transformer which was used for all the analysis under this modeling experiments. Yeah, then in terms of the data, so it was divided into two types for the model training and also testing. The first one was where the input data was not combined with the SST data. That's scenario one. Then scenario two was where the input data was also combined with SST data. And through the process of the model training and testing, the permutation importance function was also implemented, which would then give us the results for the feature importance ranking. In terms of the model training results, they are also twofold. The performance metric results when SST data was not used, and the performance metrics results when SST data was used. Yeah, under the results, we have 8 climatic zones we have obtained, and figure 3 shows the distribution of coordinates based on climatic zonal mapping using Copenhagen climate classification. Stations with SST data were identified as those close to oceans. Yeah, so figure 4 shows the spatial arrangement of 18 weather stations with sea surface temperature data from a pool of 164 stations. How the addition of SST to each zone impacted the feature importance in the transformer model. Figure 5 shows from 1 to 8 shows permutation importance analysis of transformer model after including SST data. Yeah, so for us to have a clear understanding of what is happening here, we shall use the next figure, which will sum up the results for all the 8 zones. And it was, the analysis was based on the position that the sea surface temperature occupies out of the 12 variables for each zone. So the position was changing. And so when you group them together and analyze, you come up with figure 6, which shows the position of SST variable among 12 variables by transformer model permutation importance by zone. From the figure, zone 7 and 8 were the most influenced by El Nino, followed by zone 6. Zone 1 was the third most affected, zone 5 the fourth, zone 2 the fifth. Zones 3 and 4 shared the lowest level of impact. In terms of the performance metrics for the evaluation of the models, these were used: Nash-Cliff efficiency, mean square error, mean absolute error, mean bias error, correlation coefficient, and also accuracy. Now, in terms of interpreting these, for higher error, accuracy, and NSE, when they are closing up to 1, they show a better performance. While for MBE, MSE, and MAE, when they are closing to 0, they show a better performance. So then how was this achieved in the models? So the performance metrics according to each zone before and after addition of SST. So the figure here shows the model performance for each zone, one without SST data being added, and the second one where the SST data is added. Yeah, so for us to just have a clear perspective about how this data is affecting the performance. We'll zoom to one in the next figure. So we'll zoom to model one. So, I mean, zone one. So model performance for zone one without SST data and two with SST data included in the object set. So according to this one, we see that error or correlation coefficient rose from 96.2% to 96.8%. NSC increased from 84% to 87.3%, and accuracy improved from 96.2% to 96.7%. Similarly, MBE dropped from 0.9% to 0.08, while both MSC and MAE improved from 3.8 to 3.2. So for MBE and MSC and also MAE, they have to graduate downwards for the model to be declared as an improved performance, unlike for the other three. Yeah. So then, what was the final ranking after, ranking order after calculating the variance of error, NSC, and accuracy? Yeah, so the final ranking is demonstrated by figure 9, performance comparison of models across zones following the addition of the SST variable. So in this case, this was found by subtracting the performance metrics before the SST was added from when the SST was added. So zone 9 shows an impact order from zone 5 through zones 3, 6, 8, 1, 4, 7 to zone 2 as the most affected. Now, this in figure 8, we can also make comparisons with one that perhaps it was figure 6 that we looked at earlier, which shows the SST ranking. Yeah, so zone 6, figure 6 shows that zone 7 and 8 had identical outcomes as most affected, followed by zone 6, then zone 1 with zone 5 fourth and zone 2 fifth. Zones 3 and 4 with identical values showed the lowest effects overall. Yeah, now the comparisons of these two will show us that in all the experiments, in both approaches, the significant thing is that the SST had an impact, and also, it had an effect on drought. Yeah, despite the differences in the way the ranking was not the same for both experiments. Yeah, therefore it is important to note that these differences in results may stem from randomness in algorithms, such as permutation importance, where feature values are shuffled multiple times to capture variability. Yeah, now
Excuse me,
for
sir.
final.
Yes, we request you to kindly sum up the presentation as soon as possible, as we have crossed the 10-minute criteria.
Okay. So on final insights and future directions, both approaches yielded consistent findings affirming SST's significance influence across all zones, despite minor variations in the order of effect. In terms of future works, there is need to enhance these findings by integrating additional climate indicators or exploring SST interactions with land-based climatic factors. The study provides a strong foundation for understanding and modeling climate impacts, including drought in Southern Africa, which is essential for developing effective adaptation and mitigation strategies in response to increasing climate variability and drought risk. Yeah, so those are the references, and that's the end. Thank you. Yeah, so that's the end. Thank you.
Thank you so much, sir. I'll just ask our session chairs if they have any questions for you.
I have
Ma'am,
one
sir?
question.
Yes, sir.
Ms. Prasi, hello, Mr. Jimmy.
Yes, hello.
I have one question. Mr.
Okay.
Jimmy, can you explain how you take the data set in your research?
Okay, yeah. So they were two data sets from the original point or from the onset. So we had to get the station data, which was available on a website here in Southern Africa under the Southern Africa Climate Adaptation or website under SASCAR. So that was for stations, and those stations were picked from their website. There are 164. Then the station data was used to validate the satellite data. So it was the satellite data which was then used in the modeling experiments. Yeah, and then I said there are two data sets. So we picked the data sets based on the station points, and then those station points were grouped according to climatic zones, such that we had 8 divisions for the data sets. So the experiment was run on 8 divisions. Then for the SST, a similar approach was used, but then for the SST, it's not available in all the 164 points. Yeah, so we had to get the data set according to the points that were available when you extract, from the satellite data set. So it will show that there were 18 major points that were generated, and even the map here shows, so these, there were 18 points, and then we generated data using Python codes from the satellite data for these 18 points. So it was this additional one which was used then in 2 scenarios, added or not added. Yeah.
Okay, thank you, Mr. Jimmy.
You're welcome.
Dr. Meenakshi, ma'am, do we have any questions from your end?
Yeah, actually, the same thing. Hello,
Yes, ma'am.
Yes, good afternoon. Yes.
okay, am I audible?
Yes, ma'am, you're
Yeah.
audible.
Yes, Jimmy, just tell me why you have selected your reason for this project, because the same can be happen with so many different reasons. Why you have selected this particular reason?
I cannot get your question clearly.
Actually,
Would you?
I am just asking about why you have selected this particular reason for telecommunication. Are you going to apply this mechanism practically there, or you are having any particular, or you are just working on the simulator?
Why I'm going to use which data? Are you talking about the the 12 variables or the SST data?
Yes, yes.
Which, yeah, so the SST data was used to show the significance of how the El Nino has an effect on drought. Yeah, then the other variables, the 12 of them, they were used to show the significance of what those other variables can do in terms of predictions. Then the addition of the SST would then show the difference if it was added and if it was not. Then also the other thing in the data set is found the data, such variables as temperature, maximum temperature, minimum temperature, and precipitation. So those were used also to calculate the SPEI index. Yeah, so the SPEI index was the drought indicator that was used to identify drought or no drought. Yeah, so it can either give you, it can indicate the drought conditions or the flooding conditions or just normal conditions. Yeah. I hope I've answered it clearly.
Okay, okay, okay.
Okay. Thank you.
Okay, thank you so much, sir. This brings us to the end of our session. So
Oh,
I request you to stop presenting and we'll close our session.
thank you.
Thank you so much. I sincerely thank our authors for their excellent presentations and contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9th versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springers. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I also thank our session chair, Dr. Meenakshi, and Stephanus sir. I would like to present a token of appreciation from the team of GR. One second. Here you go. Okay. These are token of appreciations from our team for ma'am and sir. As we are closing the session, ma'am and sir, I just request you if you have any final closing remarks for us presenters today. Would you like to share anything before we end the session?
I first, Mr. Rashi.
Yes, sir. You can share it.
Okay, all participants, the research present is the session is truly fascinating and demonstrated innovation solution across various domain. Uh, AI-powered poultry disease detection using CNN, microgrid voltage, IoT security, uh, CNN-based method for detecting fake beef, ERP, ENSO technology, and machine learning. And I believe this study will have a positive impact and provide solution to the problem raised the research. Thank you, Miss Prasi.
Thank you
Miss
so
Prasi,
much, sir. Yes,
you
sir.
can show my certificate. I can
Yes, sir.
screenshot. Okay.
Yes.
Thank you, Miss
Okay.
Prasi.
Uh, Ma'am, do we have any final words from you? Okay. Now, as we are closing the session, I request all of you all to kindly switch on to your cameras so that we can take a snapshot of this virtual session we just attended. All the participants who are available right now along with us and the session chairs, we request you to kindly switch on to your cameras so that we can have a quick snapshot of our virtual session. Requesting all, if possible, to kindly switch on to their cameras. Okay. Thank you so much. Now you can all log out. Thank you so much for being with us today. Thank you.
Thank you, Miss Prasi. Thank you,
Thank
all
you.
participants.
Thank you so much.